Hello, everyone. Now that we have a database in Postgres, we will connect Prisma. Prisma is a tool for working with different databases, not just Postgres, from our Node.js application written in TypeScript. It's the best solution for this. It will help us write both queries to our database and form the schemas of our tables. Let's get started. First, we need to install it. We install the Prisma Client in the backend. It will become clear later what kind of client it is. We install it as a regular dependency, not a dev dependency, because the Prisma Client directly sends queries to our database. Okay, let's wait for the installation. So, great. Prisma Client is installed. And now let's install the Prisma tools for command line usage. We are installing them in the development dependencies. Now let's wait while they install. Great. We've installed the Prisma client. Now let's create a Prisma folder inside the src folder. New folder, Prisma, and create a file called schema.prisma. schema.prisma. In this file, we will describe our database schema. But this is not the default location for this file, so we need to define in our package.json where this config, this schema, will reside for Prisma. Okay, let's insert Prisma schema and the path to this schema before the dependencies. Good. Added. Now let's describe our primary schema and add the following code to it. Look, you'll never need to change these lines. Everything below is what you add as part of your project. Well, that's conditional because you won't need to change them. You can add something here, but more on that later. Here, we've just defined our provider, that we have a database for later, and also defined where to get the information on how to connect to our database. Prisma will take the variable from process.env from the database.url variable. So, we need to somehow pass this variable to process.env accordingly. To do this, let's create a .env file and add this variable there. Okay, we've added it. Make sure you have Postgres on this port if you installed it by default and it's currently running. The port will be 5i432. This is the user, this is the password, this is the database name. But if it's named the same, you won't make a mistake here. All right? We've added the .env file. At the same time, this variable is only local for us. On the server, it might be different. Our teammate might have a third variant. Therefore, we don't need to add .env files to our repository. So what do? We add .env to gitignore. We go to gitignore and add .env to the file. Done. It's gray now, great. But at the same time, so no one gets confused later about what variables we should have, I suggest creating a file called env.example. There you can put an example which other users, well, not users, but other developers, can use to create the correct env file for themselves. We'll just name it and add the same variable there. So, and when a new person joins the project, they just copy this file and rename it to .env, and everything will work for them. They might need to edit something a little bit. Okay, we added the env variable. Prisma will look by default, but we will talk more about the .env variable later. For now, just know that we added it to this file, and Prisma will check it, find it, and take that variable from there. Okay? All right. It seems we've sorted out the connection. Let's figure out the models. Basically, your project can be broken down into some data structures. We know that right now the project has an idea. Yes, we don't even have users yet, because when we create an idea, it's not linked to anyone. And so at this moment, our data model looks something like this. Let's look at the list of ideas that we see. It has a nickname, which we know must be unique. It has a name, description, and text. At the same time, you must typically have some kind of ID. What does this model actually look like? In the first column, you write the name of your field. Then here you describe the data type. We will look at what they are. We will create more models and work with all of this. Then you can specify via the eros symbol. There are also some predefined values. That this is an ID, that its default value must be some UUID. UUID is simply a string composed of letters, numbers, and hyphens, automatically generated to ensure its uniqueness. We don't assign any default state to the nickname, but indicate that it's unique. Therefore, even at the database level, it's impossible to add a non-unique idea. The title, description, and text are regular strings. Moreover, this file formats itself conveniently, thanks to the VS Code Prisma extension. It needs to be installed too. And here, when you invoke code formatting, everything aligns perfectly on its own. Even when you make changes, it adjusts automatically, which is very convenient. All right, we have this schema, but we've only described it so far and not applied it to our database yet. Let's add the corresponding scripts to our package JSON, which will allow us to apply this schema to our database. So, well, these will actually just be wrappers around the Prisma command line, but since we'll need to call them often, I suggest setting some shortcut commands. So, first of all, let's call it PMD, short for Prisma Migrate Dev. What is Prisma Migrate Dev? Prisma Migrate Dev, seeing changes in our schema Prisma, will create migrations and run them in our database. Let's try to call this script pnpm bpmd. Here, they suggest we set a name for our migration. Well, let's say it's add. We called it, let's see what happened. A migrations folder was created automatically. This file doesn't concern us much. It's essentially a system file, and a folder was created with the name of our migration. It consists of a timestamp and the name of our migration. It contains the SQL script. We almost never need to change it manually. It's simply generated by Prisma. Here, the commands that will be sent as Postgres queries are generated. Create table request, create index request. Sometimes you can check how it all works, but in practice, you just change the schema, and then you call Prisma Migrate Dev after making changes, and it generates an additional migration to update your database models. Now everything has been auto-generated, and that's good. Let's immediately add something else. Sometimes, for instance, a developer might join, install the project, and need, well, you see, Prisma Migrate Dev creates migrations and generates corresponding types for our database. But you can generate types separately without invoking migrations. This is also useful. Types are simply generated based on the schema, and we also need these types to be generated automatically when our project is initially installed. And for this, we will set up a script called prepare. The prepare script works in such a way that it runs automatically. It's a convention. It runs automatically, provided by PNPM, and executes the command we specify here. So when a new developer downloads our project and installs it, everything will be set up, and then this command will automatically run, PNPM PGC will be invoked, and it will generate types for Prisma. All right. Right now, it may all seem like a lot at once, but we will be working with Prisma a lot more, and we will keep running these commands frequently. And why this all works like this and why it's needed, will become clear along the way. The only thing, let's add another command to our development script that will also restart our service when our end file changes, because by default, it only watches TS files. We will also see it update when the env file changes, which is also convenient. Otherwise, you might change some parameters in the env files and the server won't restart, and you won't understand why something isn't working. This is also a useful point. So, we created our first model, learned how to run migrations, and can move on. It's okay that many things were unclear now. As always, it will make more sense when we apply it to real code. We'll delve deeper into this then. Thank you. Let's move on.